Hello and welcome everyone. This is Noah again, and in this video we're going to look at factoring polynomials that have more than one variable. So for the examples that we're going to look at, we're going to be given some polynomial expressions in two variables, and get a little bit of idea of what we're doing here is we're trying to solidify our factoring skills. And so this is a bit more abstract. We don't really have any sort of application. We're not trying to solve an equation. This is just the process of factoring that we're looking at. So we've been using factoring in these finding x-intercepts applications, and now we want to just factor for the sake of factoring, just to give ourselves more practice and see some additional ways that it can be used, or some additional circumstances we might run into in future math classes as we look at more complicated expressions, and hopefully use this as a way to come up with some strategies and different ideas for how we can look at an expression and know how to factor it. Let's begin with part A, where we have m squared times n squared minus 4. So this is going to be a difference of squares. What I am looking at, what my eyes see, is that I have something squared. M squared and n squared are both perfect squares, and 4 is also a perfect square. So if I try factoring this, I can open up a couple of sets of parentheses. If I put mn in the first location, and then a 2 in the second locations, with a plus and minus, that should be our complete factorization. If we check this, just to give ourselves a little bit of comfort in knowing that we've done it correctly, we would FOIL it out. We would get mn times mn, do this off to the side, mn times mn, this equals m times n times n equals m squared times n squared, or just m squared n squared. So we'll have m squared n squared, and we'll have minus 2mn, and we'll have plus 2mn, and then a minus 4. Sure enough, the middle terms cancel, and we get m squared n squared minus 4. Not so bad, I hope. Let's go ahead and move on to part B. The first thing I think when I see this is don't panic. Like there's a lot going on here, but let's see if we can just step by step kind of dissect this and determine how we can factor this in a nice way. We have an x and a y in it. It's 4x squared minus 20xy plus 25y squared. I'm going to start, whoops, hand the bum to the screen there. I'm going to start with the 4x squared and the plus 25y squared on the left and right side. So I'm going to kind of ignore the middle term for a moment, because I want to realize those first and last terms when I factor, and then we want to make sure that what we get when we do this is going to give us the middle term. So I'm going to notice that 4x squared, straighting, my hand's just touching the screen and it pushes it to the side. The 4x squared, this is a perfect square. And the 25y squared is also a perfect square. So I'll just say these are perfect squares. So I might try 2x and 2x in the first positions, so that these would FOIL to 4x squared. And then in the second positions, since we have 25y squared, I'm sorry, I'm going to maybe restart this in a second, make sure it doesn't keep doing that. 25y squared is a perfect square. Yep, I'm going to pause this. Sorry, 1 second. All right, let's try again. 25y squared, 5y, and 5y here. And we'll try a plus, and we want it to be a positive 25, so maybe a plus again. If we do this, we get positive 10xy and a positive 10xy, and then our final term, I want to get through this video at least, I don't want to have to restart my computer right now, is going to be a plus 25y squared. But if we do that, we end up with a positive 20xy in the middle, so that's not quite right. So if I make this a minus 5y and minus 5y, we'll get a minus 10xy and a minus 10xy. That'll give us the negative 20xy in the middle that we're looking for. So that works. Notice if that wasn't a 20 in the middle, this wouldn't work. We can't just assume that the square roots are going to go in the ends here. We can start with that and hope that it works, because if it does, it's kind of just a quick way of factoring this. But we have to be sure that that when we FOIL it, the middle terms add up correctly. Let's look at part C. We have 8xy plus 8y, and I'm just going to start with a GCF. I note 8 goes into both of those. I also have a y that's in common in both of them. So if I pull out an 8y, I say if I factor out an 8y, there's an x left in the first term, and there has to be a 1 in the second term, so that if we multiply it back in, we get 8xy plus 8y. So that's a nice simple one there. Just a greatest common factor. You see, not all of these have to be too terribly difficult. Let's try another one. We've got 4y squared plus 3yt minus 7t squared. This one doesn't look as promising as the one we did before because that 7's not a perfect square, right? Up above, we had that 25 was nice. Here, not quite so nice. So if I'm trying to factor this, we might try an AC method, or we might try a guess and check method. So let's see, if I try a guess and check method, I could try like a 4y and a 1y here, and then I would need like a t and a 7t in the others. Right, so that the last terms multiply to be 7t squared. And one would have to be positive and one would have to be negative. If I try that way, then I'd have 4y squared minus 28yt plus yt. Sorry, that's a negative 28 times y times t, and then a plus y times t. And already I see that this isn't going to work out. Those don't add up correctly. I'll maybe switch this to a plus and a minus, see if that goes any better, but that's just going to be plus 28yt minus yt, so that's still not going to work. So maybe I'll switch this to the 7 over here and just a t on this other side. And if we try that, I'll get maybe a plus here and a minus here. This is going to give us 4yt and then a minus 7yt. Oh, that's promising. That gives us a negative 3yt. So that's close, but the signs are wrong. So if we switch the signs, plus 7t and then a minus t, I'll get a minus 4yt and then a plus 7yt will give us a plus 3yt. There we go. And then the last term would be a minus 7t squared. Nice. So notice when it comes to that second variable with the t, we just have to go ahead and think that that second term inside the parentheses has to have a t in it so that we get t times t is t squared. Other than that, we're still using the same methods that we developed before. Let's do a couple more here. Where we have 3 cubed minus 147r. First thing I see is a greatest common factor. We have an r that should be able to pull out of both of them for sure, and then I want to say, does 3 come out of both of these? So does 3 come out of 147? Well, 3 goes into 150. Like 150 divided by 3 would be 50, right? So 147 divided by 3, that should be a 49. That's one less than above. So that 3 times 49 is 147. Or if I write this, 3 times 50 equals 150. So 3 times 49 will be 147, 3 less. So yeah, it does. 3 goes in there, so I can say a 3r can factor out, and we'll be left with an x squared r squared minus 147 divided by 3 we determined was 49, and that r got pulled out. So we have this. This is nice. This is definitely correct, but we want to note that we're not done. This may factor further. And I also see that these are both perfect squares. So I wanted to say, does this factor further? I'm going to look at it and say, are there any methods that I can tell might work here? I see that difference of squares, so I'll try that out. 3r times a couple of sets of parentheses. X squared r squared has a square root of just xr, so I'll put that in the first places. The square root of 49 is 7, so I'll put that in the second places and put a plus or minus. And then this should FOIL out to xr quantity squared, which is x squared r squared, using our exponent rules. We'll have a minus 7xr and a plus 7xr and then a minus 49. Those will cancel. It's a minus 49, and so that all works. And so this is our final answer right there. The xr plus 7 and the xr minus 7 do not factor, and so we're all good to go. Last problem for this video. Here we have 4 terms. When I see 4 terms, I think grouping. So this grouping method's nice for the AC method. Or rather, it's used in the AC method. And so let's just practice it. If I try and group the first 2 and the second 2, let's see if it works. So it might not, but that's the first thing that comes to my mind is 4 term. Let's see if grouping will do anything for us. In the first 2 terms, I can pull out an x. I have a GCF of x. And what's left is x minus 14 when I do that. In the next ones, I would say, does anything come out of that? And I'm not real sure. 49 only factors as 7 and 7. What about 64? Does 7 go into 64? It does not. This is like 32. This is 2. This is all 2s. 2 times 32. And that's 2 and 16, etc. So no 7s go in there. This does factor. Wondering, this has a typo in it. There's supposed to be a 2 in front so that this works. So this, we can factor this second bit. It's a difference of squares. So this is a 7 minus 8y, square roots of 49 and 64, and then a 7 plus 8y. But if we do that, then there's nothing in common here. To factor out. So this, we can factor those separate parts, but that's not going to get us any further. There's nothing more we can do with that. So that's a little disappointing. I'm kind of stubborn. I kind of want to play with this for a second and see if anything else might arise. What if I just tried rearranging this? If I have x squared minus 64y squared minus 14x plus 49, just to see if anything interesting happens. If I group these two and these two, so all I've done is moved the terms around, the minus 64y and the minus 14x and the 49. I just kind of shuffled them around there. Here this would factor as x minus 8y times x plus 8y. And that's great, but the next one, I'm going to pull out a minus 7 and get 2x minus 7. But that's not really helpful any either. Is there anything else that I might want to try? X squared plus 49 is not going to get me anywhere. Yeah, I just think that this is prime. So, I mean, maybe I meant for that to have a factorization. I think I just took that out of the book. So either I made a typo and forgot something that would make this work, or this was just a prime polynomial, and that's okay. Some of these are going to be prime where you just can't factor. So we'll just conclude with x squared minus 14x plus 49 minus 64y squared is prime. It does not factor. Right? When I say, like, you know, that grouping that we did, we can factor each group separately, but I can't get something that's just like a parentheses times a parentheses at all. Right? And that's what I mean by actually factoring. We can factor parts of it, but we can't factor the whole thing. Now, as I look at this and just think about, like, what can I give you guys to help you with this? Like, I know that a problem like this is going to be something where if you see it, you're like, how do I know that I'm done? How do I know that there's nothing more to be done? It's a hard question to answer because it really comes with practice. It comes with being familiar with all of the techniques and seeing that none of the techniques are really going to work here. Like at the beginning, I can't add any like terms. I can't simplify it at all to be able to do anything there. So really grouping is the only option for this. And I've tried grouping it in a couple of different ways. I mean, I could keep trying, and honestly, I kind of did in my head. I said the other option would be to do x squared grouped with the plus 49, and then have a minus 14x minus 64y squared. But then this doesn't factor at all. So here, the most I could pull out is just a 1, which really isn't pulling anything out. And I could pull out a minus 2 definitely goes in. Any more than that? 2 goes in, and 7, no. Minus 2 would leave me with a 7x plus 32y squared. And so again, we don't have anything in common to pull out. So I've tried all the different groupings, and there's nothing in common in any of the cases where we can pull anything out. So we're just stuck at this point. There's nothing else to try. And so it really comes down to being familiar with you know you've tried everything you can and haven't gotten anywhere. So, you know, it's a learning process. Don't put the right away. More think of this as, okay, sometimes I'm not always going to know what I need to do, and that's okay. If you want to ask for help, I'm here to be your guide. So if you have a problem that you're not completely sure on and you want to check yourself, you know, send an email and we'll see if we can't get that squared away a little bit better. All right, everyone, we're going to wrap this up here. Thank you so much for watching. Give it a now go, see what you can come up with. And in the next video, we'll go ahead and walk through those solutions.